Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the periodic properties within a group. In today's lesson, we will explain the general trends in properties of elements down a group of the periodic table. The trends we will discuss include nuclear charge and atomic radius. Let us begin. Elements that are found in the same group on the periodic table show similar chemical properties. These elements also have the same number of valence electrons. For example, group 1A elements all have one valence electron, while the elements in group 2A all have two valence electrons, and so on. Thus, it is often possible to determine the number of valence electrons an element will have based on its group number. The nuclear charge and the effective nuclear charge both can be used to explain the periodic properties of the elements. Nuclear charge is the total positive charge in the nucleus of an atom. An atom's valence electrons, which are the outermost shell electrons, are attracted to the nucleus of the atom. At the same time, they are repelled by the inner shell electrons. The attraction between the valence electrons and the nucleus is reduced because the inner electrons shield or screen the valence electrons. This results in a reduced attraction between the nucleus and valence electrons. Effective nuclear charge is the name of the net positive nuclear charge that attracts the valence electrons. Effective nuclear charge relates the nuclear charge to the number of shells an atom has. It is the difference between the nuclear charge Z and the inner electron that screen the valence electrons. The effective nuclear charge is always less than the actual nuclear charge. Let us look at an example. A sodium atom has 11 electrons. The 10 inner electrons completely cancel the 10 units of nuclear charge on the nucleus. Thus, the inner electrons screen the valence electrons from the full attractive force of the nucleus, leaving an effective nuclear charge of +1. The fact that the inner electrons shield or screen the outer electrons from the full charge of the nucleus is known as shielding or screening effect. Students, let us do an activity. In a moment, you will see several sentences that relate to what we have just learned. However, several words will be missing from the sentences. Please use what you have learned to fill in the missing words to complete the sentences.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to fill in each of the missing words? Let us go through them together so you can check your answers. The valence electron's attraction to the nucleus is reduced because the inner electrons screen them. Effective nuclear charge is the difference between the nuclear charge and the inner electrons that screen the valence electrons. The effective nuclear charge is always less than the nuclear charge. If you were able to correctly fill in all of the missing words, then you did very well. Students, if we move down any group of the periodic table, the nuclear charges will progressively increase. However, the effective nuclear charge remains nearly constant. Take a few seconds to look at the table now. Let us move on and discuss atomic size and atomic radius. It is quite hard to measure the size of an atom directly. This is because the electron cloud that surrounds the nucleus does not have a clear boundary. In other words, its electrons do not have a fixed distance from the nucleus. Therefore, atoms do not have definite outer boundaries, so the size of an atom must be defined in terms of its atomic radius. When we move down a group on the periodic table, the atomic radius of the elements depends mostly on the number of shells it has. Let us look at metals as an example. The atomic radius of a metal is defined as 1/2 the distance between the nuclei of the two adjacent atoms. For the elements that exist as diatomic molecules, which are molecules that are composed of only two atoms, the atomic radius is equal to 1/2 the distance between the nuclei of the atoms in the molecule. Chlorine is a good example of this. As you can see in this image, the atomic radius of a chlorine atom is 99 picometers, which is half the distance between the nuclei of the two atoms. 1 picometer is equal to 1/1,000,000th of a meter. Students, for the elements beryllium, magnesium, and calcium, please indicate the shielding shells, the shielding electrons, and the effective nuclear charge. You may begin now.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, students. I am sure that you had no problem with this activity. Beryllium has 2 shielding electrons and an effective nuclear charge of +2. Magnesium has 10 shielding electrons and an effective nuclear charge of +2. Calcium has 18 shielding electrons and an effective nuclear charge of 2 as well. In today's lesson, we learned about some general trends in properties of elements down groups of the periodic table. We looked specifically at nuclear charge, which is the total positive charge in the nucleus of an atom. The nuclear charge of elements increases as we move down the periodic table. We also looked at the atomic radius of elements, which varies depending on the number of shells they have. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.